Hello everyone, welcome back to our video class here at CSEC Math Tutor. We are doing some measurement today, and in this lesson we are going to be focusing on how to calculate the area of irregular shapes. Very interesting topic, and I'm sure that you're going to learn a lot just by going through it with me. So our objectives are for today to calculate the area of an irregular shape by counting squares. And of course, we're also going to use some metric units and scales as we go along. Now, from time to time, we're asked to find the area of a shape, and that shape is irregular, and we do that by counting the squares, and that is the method that we're going to be using. And we're going to be looking at these simple questions first, and then we're going to shift to questions that CXC will throw at you, where you will have to use the method of counting squares to find your answer. So here in this diagram, it's made out pretty simple because I want you to understand the idea of how to count squares to find the area of a shape if you have never done it before. So here we have a triangle, and notice that you have some F's and H's, and the F here would is representing what we call full, and the H represents half. So the F represents full and the H represents half. So the idea here by counting squares is to go through the diagram and see how many full squares you have and then how many half squares you have. So in this case, we have, in terms of full squares, 1, 2, 3, 4, 5, 6 full squares. And in terms of half squares, let me just put that in a different color. We have 1, 2, 3, 4. So in terms of half squares, we have 4 of them. And in terms of full squares, we have 6. So we can say 4 times a half is 2, and 6 on this side, and in total we'd have 6 plus 2, and that would tell us that we have 8 unit squares, whatever the unit is. For our purpose, let's call them centimeters. So in our case, we'd have 8 centimeter squares. So the total area of this triangle would be 8 centimeter squares, and that is how we go about finding the area of the triangle by counting squares. You count the full ones first, you count the half ones, and in some cases you can go further and count quarter. And so in this one here, let's go through and count the full ones. So here, 1, 2, 3, 4, 5, 6, 7, 8. So in terms of full and half, it will not always be full and half, depending on the shape that we're dealing with, but we'll get to that. So we have 8 full ones, and in terms of half squares now, let's look at the half. So we have 1 here, 2, 3, 4, 5, 6, 7, and 8. Of course, you could say that this half and this half makes 1, this and this makes 1, this and this makes 1, and this half and that half will make 1. So we have 8 half squares, which gives us 4. 1, 2, 3, 4. And so 8 plus 4 here would give us 12. And so the area for our shape would be 12 centimeter squares if we're using these as centimeter squares. The question will often tell you what to use in terms of what each unit square on your diagram represents. Now let's look at another question where the shapes are not so evenly drawn. So in this case, we have the diagram below shows an island, and each square on this map represents 1 kilometer in length on the actual island. So each square is 1 km in length. By counting squares, estimate the area of the island. And so first I'm going to set up full squares, and let's call some 3/4 and half, in case we have those. In some cases, you'd have to leave off bits and pieces because it's not enough to estimate. But let's go through and see how many full ones we have. We can just write them in. 1, call that's 2, 3, 4. This is almost 1. So I'm going to call that 5. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yes, 16. This is also almost 1. So I'm going to call that 17. 18, 19. That is too far off. So this one is almost 1. So I'm going to call this 20. So here I'm going to say that I have 20 full squares. Now, you can use your powers of judgment to say, all right, this one right here, if I should take this piece and put here, I could almost get a square. So this piece put here would give me 21. Yes. This is more than a half, so I could call this 3/4. So let me use the method that I said I would use. So this would be 3/4. I'm going to put it in green. This would be another 3/4. That's 2. This one 2, 3. Which one is almost full again? Almost full. This is a little bit more than half, so I'm going to call it 3/4. So that would bring me up to 4, and that looks like it for the 3/4 ones. So I have 4 of them, and now for my half ones. So the half ones I'm going to put in a different color. So this is like a half. So this is 1. That's also like a half. It's a little bit more, but you can estimate it there. Was 1, 2. This is like a half. 3. This one 2. 4, almost like a half. This is too small, so I'm going to leave that. That's too small. That's too small. And these pieces here are too small, so we can leave that. Remember, the idea of the question is not an exact answer. Rather, we're looking at the best estimate that we can find. So we are at 4. 1, 2, 3, 4. Skip those. And we are here. This is almost like a half again, so we can go 5. And this is less than a half, so we can skip it. And this one is almost like a half, so we can go 6. And we have accounted for most of them. So we have 6 times a half. Of course, you could go through it in a more refined way and come up with a better estimate. So here we have 20 full ones, and then do this calculation. Gives us 3 full ones here, and 6 halves would give us 3. And so going through it, we'd have 20 plus 3 plus 3, and that gives us a total of 26 kilometer, 26 squares. 26 squares. Now each square is 1 kilometer by 1 kilometer, which is why I wrote 26 kilometer square. So it's 26 km square. So the estimate for the islands, the size of the island, would be 26 kilometers square. Maybe a little more, maybe a little less, depending on how you went about it. But the idea is, first you go through, you count the full ones, and then you count the 3/4 ones or the half ones, and then you use that to build up your answer and to find the best estimate that you can. Now, how does CXC apply this, and how are we expected to answer questions from CXC with this idea? Let's look at 2 questions. Here we have a question that says the diagram below shows the map of a golf course. Let me see if I could make this a little bigger. Well, it's as big as it can be. The diagram shows the map of a golf course drawn on a grid of 1 centimeter squares, and the scale of the map is 1 to 4,000. What this means is that 1 centimeter on the map represents 4,000 centimeters on the actual ground. Remember now that 100 centimeters make a meter. So 100 cm gives you 1 meter, which means that if we divide this 4,000 by 100, it's going to tell us that 1 centimeter on the ground, on the map, means 40 meters on the actual course, on the actual golf course. So it's 1 cm to 40 meters. Now it's given as 1 to 4,000. It's up to you to decide how you want to how you want to deal with it. I'm doing it right now because further on it's going to ask me to give my answers in square meters. So the first part of my question here says we must find the area on the ground, that is the golf course, represented by 1 centimeter square on the map. So 1 centimeter on the map, this section here would actually be 40 by 40. 40 meters long, 40 meters high, and 40 meters by 40 meters would give us 1,600 meters square. So 1 centimeter on the map, 1 centimeter square on the map would actually give us a distance, or rather an area of 1,600 meters square on the golf course, because 1 centimeter would mean 40 meters. And so we multiply our 40 by 40. And the second part here, the actual area of the golf course, giving your answer in square meters. And here is where we're going to use our technique of counting squares to get our answer, to get our estimate for the area of the golf course. Now let's write that up. So I'm going to put full and 3/4 and half. And then we go through it and see how it works. So let's start off with the full ones. Here, this is almost full, so I'm going to call it full. 1, 2, this one is almost full. 3, 4, 5, 6. Let me get rid of these two numbers here. That's too far off. 7, this is almost full. 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay. Go across here. 20, 21, 22. That's too far off. 22. All right, let's leave that at 22. So we'd have 22 full ones. This is a little bit, comparing here and here, we wouldn't call it a full one. So we have 22 full one. Now let's go for the 3/4 ones. I'm going to put that in a different color here so we can look at it. So we have 1, 2, 3, 4, and call this one 5. So we have 5 that are 3/4, and then let's go look at the half ones now. And the half ones, this is too small to be half. That is too small to be half. This is about half though. So we can call this one half. That's too small to be half. And this one is about half. So we have 2. There's a half here, 1, and there's another half here. So we have 2 of them. And now we're going to do our calculations. So 5 3/4 ones. Here would give us 5 times 3/4, and that's 15. 15 divided by 4 is that's 3.75. And here we have 22, and then 2 halves make 1. So our estimate is going to be for this question, in terms of number of squares, we have 22 plus 1 plus 3.75, and that would give us a total of 22, 23, 25.75, and 25.75 squares. But remember, each square represents 1,600, and so the actual area of the golf course is going to be 25.75 times 1,600 meters. And once that, we can just punch into our calculator and get the answer. 25.75 times 1,600, and that tells us that the area of the golf course is approximately 41,200 meters square. So the idea is to go through, like I said, look at the full squares, then you look at the three-quarter squares, then you look at the half squares. Incidentally, this is a useful technique that is used in the sciences, especially when you want to find the area of, for example, a leaf or some irregular object. It's the same idea. You go through, you count the squares after drawing your object on a graph paper. So let's look at the last question. Another question from CXE here. Let's look at our scale first. The diagram below shows a map of an island drawn on a grid of 1 centimeter squares. The map is drawn to a scale of 1 to 50,000, which means that every centimeter on the map, so 1 centimeter on the map means 50,000 centimeters on the ground. 50,000 on the ground. All right. So we can change this, modify our numbers, because we know that 100,000 cm makes 1 km, and so we can convert our 50,000 cm therefore would be equal to 0.5 km. So 1 centimeter on the map would be equal to 0.5 km on the island. And those are important to do when you're working out a question like this. So the area shaded area on the map is a forest reserve. So this section is a forest reserve. It does say so. By counting squares, estimating centimeter square, the area of the forest reserve as shown on the map. So we're going to calculate based on what is on the map. So we can set up our thing by saying full, half. You don't always have to set this up, but it's useful to do so. So full, three-quarter, and half, and we can just leave the other pieces because it's our estimate. So let's look at the full ones first. Full ones, that's full. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is almost full, so I'm going to call this 11. Likewise, this one is almost full, so I'm going to call it 12. So I have 12 full ones. And in terms of the three-quarter ones, no, I don't have any three-quarter ones. This is almost three-quarter, but it's closer to half than three-quarter. So I'm just going to drop a 0 in there and use the half ones. So I'm going to count them. 1, 2, 3, 4, 5, 6 half ones. So it's 6 times a half, and 6 times a half is 3. So in terms of centimeter squares, by counting squares, estimate in centimeter square the area of the forest reserve as shown on the map. That's 12 plus 3. So in part 1 here, we end up with 15 centimeter square. So this is our approximation for the area of the forest reserve as seen on the map. Now, the next question is now to calculate in kilometers square the actual area of the forest reserve. So in the actual forest reserve, each centimeter is 0.5 times 0.5 of a kilometer. So here we have it, 0.5, 0.5. And so 0.5 times 0.5 gives us 0.25. And so this is the area of 1 square. But we have 15 of them. And so for part 2, since we have 15 of those squares, to find the area in kilometers square of the actual forest reserve, we go 15 multiplied by 0.25, and just punching that into our calculator very quickly, we get 3.75 kilometers square. And so that would be the area of the actual forest reserve. It's a very, very useful technique for finding the area of a regular object. CXE often puts this on your exam paper. And as you can see from these two past paper questions, it is something that is worth learning. I hope you would have gained some understanding of how to use the technique of counting squares to find the area of an irregular object. Thank you for watching, and continue working hard as you prepare for your exams.